and then just get up and leave when it's time for you to go, and I'll just carry on. So we're looking at the Numeracy Paper 2, Calculator Aloud from November 2020. And if we just do what we normally do with the grade boundaries, so we know what we're aiming for. Grade E 20, grade D 30, grade C 40, grade B 52. That's what you're looking for roughly out of 80 in order to hit those grades. So if you get question 1 right, you got 5 marks. If you got 1 and 2 right, you got 12. 1, 2, 3 right, 19, 29, 29, 32, 38. So by the time you get to the end of question 7, which are all easier questions, you're into the grade C. 45, 49, 60. So by the time you get to the end of question 9, you've smashed to grade B. So that gives us a sense of the grade C. I'll stop at the end of question 7 and see how we're getting on.
So you get every single one right and you get a B.
If you get 80 out of 80,
Yeah.
you get a B, because you're not being tested on any of the grade AA star work. Yeah? Right, so then they give you these formulas. Okay, so they give you the area of the trapezium. We used that last week. They give you the volume of a prism. But when you come to sit down, if you're rubbish at remembering things and you've got things going through your brain before you come in, there's lots of things you can put on here to refer back to. Okay? So you've got your triangles. You might want to put those down. You might want to put your Pythag down. You might not, doesn't matter. You might want to remember how to find the area of a circle, depending on whether you've got the diameter or the radius. So area pi r squared, circumference 2 pi r, or pi times diameter. You might need to remember the metric imperial equivalences that I told you last week. 8 kilometers is approximately 5 miles. 1 kilogram is approximately 2.2 pounds, and the other one was 1 inch, I think it was, wasn't it? Was it a litre? Yeah, I can't remember now. Yeah, sorry. 1 kilograms is 2.2 pounds, and 1 litre is 1.75 pints. You may need to use that in the paper, you may not. Volume of a cylinder. If you've got the radius and the height, the volume pi r squared h. Okay? The more times you write those down, the less likely you are to need to write them down, because you'll memorize them, but it's just useful. Drop those on the front page and they're there then if you need to refer to them. Okay? Okay, let's start then. So question 1. Maldwin sells flags, scarves and hats. Oh, not a fire alarm.
Interruption. We just announced that there will be a fire test going off very shortly now. It's a fire test.
You have to go outside?
No, it just sounds horrible. Yeah. For about 30 seconds.
Is that why they have this?
Okay, so Maldwin sells flags. We'll keep going until it goes. Maldwin sells flags, scarves and hats outside the stadium. At the end of a football match, Maldwin sells his remaining flags, scarves and hats at sale prices. So the scarf, he was flogging it for £4.97. Now he's given 3/7 off in the sale. And the flags, £8.50 each. Buy 2 and get 26% off the total price. So the first thing, calculate the sale price of a scarf. So we're working with a scarf. Two ways you can go about this. You can either work out what 3/7 is and take it off, or if they're taking 3/7 off, what fraction is going to be left? 4/7. That's not so bad, is it? That's not so bad. We keep going. Okay, so the sale price is going to be 4/7 of £4.97. Okay, that's the maths we got to do. On your calculator, the fraction button is that one there my pen's pointing to, the sort of square on top of a square. So if we do 4 on top, 7 on the bottom, times 4.97, and then turn it into a decimal, it gives you the £2.84. So that's the quickest way of doing it, is in your head saying, well, if they're taking 3/7 off, that means it's going to cost me 4/7, in the same way as the reverse multipliers that we were doing in percentages a couple of weeks ago. Okay, so you could do it that way, or find 3/7 and then subtract it. Calculate the cost of buying 2 flags in the sale. So if I'm buying 2, I get 26% off. So they're going to cost me 100 minus the 26, 74% of the total, yeah? So cost 74% of, and then I've got to buy 2 flags, so they're £8.50 each. So I've got to work out what 74% is of that £17. On your calculator, you've got a percentage button. If you've got this version, the percentage button is above the open bracket. If you've got this version, the percentage button is above the answer button at the bottom. So depending on which one you got, they work the same way. You just got to type in 74% times 17. If you're happy writing it to 74 over 100 times, that's fine. If you're happy turning 74% into a decimal, 0.74, whichever method works for you. But you have got that percentage button to use. So that comes to £12.58.
What's that say, cost?
Cost, yeah. So both of those are worth 2 marks each. If you just write down £2.84 and you just write down £12.58 with no workings, you get the marks, because there's nothing there saying show your workings. But if you write down 4/7 of 497 and then for some reason you press the dodgy button on your calculator, you get 1 mark because you're showing your method. Okay, so it's always worth putting that line of maths in just to back yourself. Before the sale, a hat cost £3.99. In the sale, the hat costs £2.66. By what fraction has the cost of the hat been reduced? So to turn that into a fraction, you want to work out what the reduction is over the original value. Okay, so we work out the top part of it is going to be £3.99 minus £2.66. The bottom is going to be the original value, which is £3.99. So £3.99 minus £2.66 is £1.33 over £3.99, and then get your calculator to do the work for you. You'd matching that up with one of those fractions there, but using your fraction button, you've got 1.33 on top, 3.99 underneath, and the calculator will tell you that that's equivalent to 1/3. Okay, that question could have asked you what the percentage reduction was. If it did, it would still be reduction over original value, but then you times it by 100 to turn it into a percentage. just because a question gives you a list of possible answers doesn't mean you don't need to do any working to get the answer out. Anything on that page you want me to go back over? No? All happy? We're in grade E land here, yeah? Or in grade U land here, actually, if you don't get any of them right. You're not going to grade. But hopefully you're alright with that. Alright, Joseph? Yeah. Number 2. Right, so this is the OCW question. So part of this is going to be for how you lay your work out. Who buys peanuts to feed the birds? He finds the following prices for buying peanuts. So you've got Bird Feast, £16.20 for 12.55 kilos. Cheap Feed, £32 for 25 kilos. And Kind to Birds, £15.60 for 12 kilos. Which of the above options is best value for money? So in any best value for money question, you want to make them comparable. So you want to have the same quantity and work out what the cost is. Okay? So because we're all working each weight here, each mass is in kilograms, the easiest thing to do is find out how much would a kilogram of that one cost. How much would a kilogram of that one cost, and so on. You happy doing that? Yeah? So work out cost per kilogram. Bird Feast. So in order to work out how much a kilogram of Bird Feast nuts cost, what maths do I have to do to get a single kilo?
16
That's it. 16 divided by 12.55. Yeah? So it's £16.20 divided by 12.55. So what? So 16.2 divided by 12.55. So £1.29. So then we'll do Cheap Feed, which will be 32 divided by 25. £1.28 per kilo. And then Kind to Birds, 1560 divided by 12. £1.30. So I've done the maths. I've now got to make a decision as to how do I use that to decide which is the best value for money. And which one is it? Cheap Feed, yeah? Because it's the cost the least per kilogram. So Cheap Feed is best value for money. And that's 7 marks. You get the additional 2 for that. You're basically saying at first line what you're doing in order to make the comparison. Yeah.
Wouldn't it just be 1.22 because it's 1.2 here?
Which one are you doing, Tom?
Bird Feast.
Bird Feast.
It'd be £1.22 or 1.29.2 here.
£16.20 divided by 12.55. No. If it was 1.2 recurring, you wouldn't have all that after it.
Yeah.
If what you've got there is a string that is going to recur, but we don't know yet what the... So the recurring part of it is going to be 1.29 all the way until we see the next dot. Okay? Okay? So that's not the only way to do the comparison. We went for the cost per kilogram. What you could have done is work out how much a kilogram of bird feast costs by doing 12.55 divided by, how much you get for a pound in bird feast by dividing 12.55 by 1620. How much you get for a pound with that one by doing 25 divided by 32. And the key thing is you're fixing one thing so that it's directly comparable. Question 3. Venn diagram. So there are 34 pupils in class 10A. Dewey carried out a survey to find out how many of these pupils take part in swimming, running and judo. He displayed his results in a Venn diagram as shown below. Okay? So, I'm not sure, would you have done Venn diagrams? Because they weren't part of the course last year in COVID.
Yeah,
you have done them. Yeah. So you know that the number of kids representing swimming is everybody within that swimming circle there, yeah? And then the running circle is that one, judo is that one. And then where the circles overlap tell you how many are doing more than one activity. So how many of the pupils in class 10A take part in both judo and running?
4.
Okay, so we've got a 1, a 4 and a 12. It's 4, yeah? Judo and running are, that person there is only doing judo and running, but you've also got the 3 in the middle who are doing judo, running and swimming. So it doesn't say only judo and running, so it's 3 and 1 is 4. How many of the pupils in 10A take part in swimming?
21.
So that's that full bundle there, which is 9, 18, 21. How many of the pupils in class 10A do not take part in judo?
20.
24.
20.
So how many do take part in judo? This circle. So that's going to be 10.
Oh, the 4 on the outside. Oh,
Yeah.
Really fair play.
10, and those 4 don't do it. 14, 20.
Oh, it is 20. Got the 4 on the outside. It is 20.
It is 20, isn't it?
The 4 on the outside.
4 on the outside.
Yeah.
So it's 30.
They're not taking part in judo, are they?
34, hang on. 34 minus those 4 minus this.
Yeah, but it doesn't say to leave out those 4. It just says the ones that are. It just says the ones that are doing judo. And they're not doing judo. They're not doing anything.
How many of the pupils in class A do not take judo?
And they're not taking part in judo, are they? But they're still in class.
Yeah.
Yeah, so they're still in it. So you don't say mark there. It says 24.
Sorry, you're right, Tom. You're right. Yeah.
Yeah, Tom is right, surely.
Yeah, Tom is right.
Because that 4 didn't take
Yeah, they didn't take judo. So I'm taking out of the 34 the ones that do take judo, which are those 10. Yeah. You only need the angle measurer, the circle. Right. Then we got calculate the percentage of pupils who do not take part in swimming, running or judo. So first thing to figure out is how many of them do not take part in running, swimming or judo. Which is 4. Out of what the total is. 34, yeah? So if the question asked you what fraction didn't take part in swimming, running or judo, that would be your answer. But because they want it as a percentage now, you have to multiply that by 100 to turn it into a percent. So, fraction button, 4 out of the total, which is 34, times 100 to turn it into a percentage. And then they want the answer given to one decimal place. So it's either going to be 11.7 or 11.8. Which one?
11.8.
Good. Because the next one along is bigger than 5. So 11.8%. So let's Venn diagrams of percentages. Pie chart. 1,080 people were asked to choose their favourite vegetable. The pie chart shows the results. How many people chose broccoli as their favourite vegetable? You must show all your working. So this one now, it's telling you you've got to show some maths. So if you just wrote down an answer and fluked it, you wouldn't get the mark. So that pie represents 1,080 people. So in order to work out how many are represented in this slice, we've got to work out what fraction of the whole slice that is. Okay? So the whole pie would be out of how many degrees? 360. The number of people represented by the pie is 1080. So what we have to do is work out how big that angle is.
Oh,
So you put the middle of the measurer at the centre of the pie. You line 0 up with one side of the slice you're trying. I thought it had gone off.
Again.
what? Fire alarm?
Yeah.
Oh, when
you've done a shot.
What, do we have to stay in?
Yeah, we don't have to go, they just make a noise.
No, I'm saying it's like
Okay, so you should get 55 degrees. Okay, anybody not sure about that? So then to work out how many people liked or chose broccoli, you back to your calculator, fraction button, 55 on top, 360 times 1080. So I've typed it on the calculator exactly as I've written it. 165. You're right, Joseph.
Is it 15.3?
What? No.
Oh, I thought it was 100.
No. No, you're measuring. You're writing the slice as a fraction of the whole pie, yeah? Okay, so that is that one. B, or part 2. How many more people chose carrots than chose sprouts as their favourite vegetable? So there's carrots, there's sprouts. How many more people chose carrots than sprouts? What are we going to do? There's 2 different ways of approaching this. What's your thinking?
Work out carrots.
Work out how many sprouts there are, and then work out how many times the amount of that there is in the carrots.
So you'd work out both the number of people for carrots and then take it away. Yeah. So that's probably what I would expect. What you could have done is measure both and work out the difference in the angles and then turn that. Oh, there you go. So carrots then. So same thing now, carrots. Okay, so we're going to measure both of those angles. So carrots, centre at the centre, line the 0 up with one side of the angle and measure the other. So I reckon that's 100 degrees for carrots. And then sprouts, 35?
Yeah.
Okay, so fraction button 100, 360, 1080, 300. Sprouts 35, 360,
Oh, fractal sprouts.
105. So 195 more.
Nathan's there for a chocolate, mate. Vegetable.
I'm so funny on this.
So 195 more chose carrots. So that ends the pie chart question. Part B. Right, this is one where we need to read it carefully. So 420 selected peas as their favourite. They were asked which they preferred, fresh, frozen or tinned. Of these 420, 3/14 said they preferred fresh. Twice as many preferred frozen to tinned. How many of these preferred frozen peas? Right. So we got two different steps we got to take here. Okay, so first of all, we know that in this peas section there are 420 people. Okay? And 3/14 of them preferred fresh peas. So what fraction didn't prefer fresh peas?
Over 38. No, it's not. It is
11/14, yeah? So 11/14 out of the 420. Yeah, because the total fraction is out of 14. Yeah? And 3 out of the 14 preferred fresh. So 11, they got to add it to 14 out of 14, yeah? So 11/14 times 420 now. So we're not working with 1080 anymore because we're working with that smaller fraction of people. 330 preferred either frozen or tinned. Okay, come on boys, focus. Boys. So 330 preferred either frozen or tinned. And I know that twice as many preferred frozen peas. No, sorry. Yeah, twice as many preferred frozen to tinned. So if you think of it as a sort of ratio, if I got frozen to tin, twice as many preferred frozen to tin.
Then you have to divide it by 3.
So you divide that by 3. Yeah. So 330 divided by 3 is 110.
Yeah, frozen peas, isn't it? Most
So-
things frozen.
Twice as how many people preferred frozen? So that's tinned. So frozen will be 220.
I know tuna. Yeah. Sweet corn.
Right, boys, get a grip of your stomach now and your appetite.
What's you prefer, sir? Frozen.
Mushy.
That's so good.
Underrated.
Oh, you're gonna love a mushy.
Only on a chip, only on a chip.
Anyway, come on.
Yeah, I don't know.
So there's lots going on in that question. They're starting off with a fraction to work out how many preferred, so taking out the ones that preferred fresh. Then they're telling you that once you've got those 330, they've been split in the ratio 2 to 1 because you've got twice as many preferred frozen to tin. So that gives you your 3 parts. So you divide the 330 by 3. So 110 preferred tinned and then double that for frozen. Okay, so lots of arithmetic taking place. Question 5. Now this looks like a monster question, but actually it's quite straightforward. So each week in Ysgol Derwyn, the head teacher calculates the mean attendance for each class. Okay, so mean, this is something similar to what we were doing last week. This is the mean number of half days per week that students have attended school from Monday to Friday. There are 5 classes in year 11. The head teacher has partially completed a table recording week 1 attendance for each.
Oh my god.
For each class in year 11 as shown below. So, class 11A, okay, just like when we were doing these in class last week, pick a row and make sure you can make sense of it. So this is saying here that in class 11A there are 28 pupils. When you add up their half-day attendances for week 1, they came to 238. So the mean attendance is 8.5. So where did that mean attendance come from? So just to make sure we're getting the maths right here, that top row is giving you all the answer, all the numbers from the sum. Okay, so if we do the total 238 by the count 28, we should get 8.5. We do. Okay. So in order to work out what that one there is,
Do you times them together?
instead of dividing, it's the reverse. Yeah, it's the reverse mean that we were doing last week. So to get that, I'm going to do 25 times
I didn't understand that.
25 times 7.4 equals 185. Who said they didn't get that? Fine.
What? No, I didn't think that
Well,
last week.
Right. So, well,
No.
but that's fine. They're giving you, so in order to get that 8.5 there, you're going to do 238 divided by 28.
You times 25 by 7.4 there.
So to go the other way, you're going to times it, yeah? Because they're giving you the output, you want to work out the input. Same for this one then. So to get the gap there, I'm going to do 32 times 9.5, 304. And for this one, I'm going to do 25 times 6.6, 165. Then I've got to work out the totals at the bottom. So the clues in the word total, I'm going to add those up. 28 plus 25 plus 32 plus 30 plus 25. I did the times then. 28 plus 140 And the total attendance,
Actually, no way.
so we completed the table, hence calculate the overall mean attendance for all of year 11. So what am I going to do now to work out that overall mean attendance?
5.
Divide what by what?
1162
Yeah,
by 140.
40. Yeah, so the total divided by the count. The total is the total attendance, so that's 1162, and the count is how many pupils we got, which is 140. So 8.3.
A whole language. But we're not, I think it's too dry.
You're not lukewarm.
Okay, and when you look at that, I'm looking at the figures in the mean attendance for each class, and that looks about sensible, doesn't it? They're all in the 7 points or the 8 points or the 9 points, so I'm quite confident that I've got that right. Okay, happy with that? Right, number 6. So this is a tax question. Last year, Simone's total income before tax was 30,000 euros. The tax bands, taxable income and tax rates last year were as follows. Okay, come on guys. We're going to do a lesson on taxation week after next probably, okay, but I'll just explain it now. So, Thomas, shut up, will you? If you don't want to focus, go. So Simone's total income was 30,000 euros. She has to pay tax on that, but the tax varies in certain little chunks of what she earns. So the first 4,000 euros that she earns, no tax. Okay, so 4,000 at 0%, no tax. The next quantity that she earns is at 15%. Okay, so everything that she earns over 4,000 and up to 10,000 is taxed at 15%. So let's say that she was only earning 8,000 euros a year. If she's only earning 8,000 euros a year, the first 4,000 would be no tax, and then the amount that she earns between 4,000 and 10,000 would be at 15%. So her 8,000 earnings, 4,000 is in this band, so she would earn that. Because she earns over £10,000, all of that amount of money would be taxed at 15%. So how much money is in that band? 6,000. So she's going to pay 6,000 at 15%, and then we're into the higher rate. So the higher rate is everything she earns over 10,000. And because she earns 30,000, how much is she going to be charged at that higher rate? So we're splitting the 30,000 up into first 4,000, next 6,000. How much of her earnings is over 10 grand?
20 grand.
20. And that's going to be taxed at 22%. Okay? So that adds up to her total earnings, 30 grand. 4,000 of it she doesn't pay tax on. 6,000 of it she pays 15% tax, and the rest of it she pays a 22% tax. Now for part A, all they want you to do there is the basic rate, which is this one. So the basic rate you're going to do 6,000 times 15% using the percent button, or times 0.15 if you want to turn it into a decimal, or times 15 over 100, depending on how you're comfortable writing percent. Okay, so that's your 900 euros. Calculate Simone's total tax bill. Well, I've written it up here now. Okay, so this is your personal allowance. That's your basic rate. That's your higher rate. So, because I've laid it out up there, we may as well stay up there. So the higher rate is going to be 20,000 times 22%. So Simone's total tax bill for the year is going to be the sum of those three. It's going to be 900 plus 4400. So she pays 5,300 euros. So as I said, we will do a lesson on that later on this half term, but that's basically all it is splitting up the value of her earnings into those three bands.
So for 4 marks, look, 900.
Yeah, it's just because I've written it all in that part A, Tom. You only needed to put that middle one there, but because I was explaining it, Rhys? Stretch. Okay, question 7. So this takes us, into the grade C work then. Okay, if we've got everything right up to these 7 marks, and we get these 7 marks, we've got a grade C. So it's another one with a lot of words and numbers. In May 2018, the population of Wales was approximately 3,150,000. Out of that population, approximately 286,500 were age 75 or over. So those are numbers, they're people. In May 2018, a survey in Wales found the following. 85% of the population use the internet. 99% of people aged 16 to 24 use the internet, but only 40% of people 75 or over use the internet. In May 2018, how many people in Wales did not use the internet? So it's not a percentage I'm looking for, it's a number of people who didn't use it. Okay, so if 85% of the population used the internet, 15% did not use it. But 15% of what number?
The whole population.
Yep, so which number is that, Scarlett?
The top.
Top one, yeah, 3,150,000. So 3,150,000. So on your calculator, 15% times 3,151,234. So 472,500. Okay, happy with that? Of all the internet users in Wales, what percentage were aged 75 or over? Give your answer correct to 2 significant figures. So it's a percentage we're after of old people, and in order to get 5 marks, I've also got to round to significant figures. Okay. So in order to turn that into percentage, I need to know the number of internet 75 or over, and I need to divide that by the number of internet users, and then I need to times it by 100. Okay, so that's the maths that I've got to do to answer the question. That'll give me the percentage. So the first thing I need to do is work out how many internet users there were, and also how many of the internet users are aged 75 or over. So 85% use the internet. Okay, so we can either work out what the 85% is, or because we've already worked out how many didn't use the internet, we could just take that away. Doesn't matter which way you do it. But since I've written down the 85%, now we'll go that way. 3, 1, 5, 1, 2, 3, 4. So that's how many internet users there are. Then it says,
See, why do people put that line across the 7?
sorry, what?
You know the 7, you do that
Yeah.
across it?
Just habit.
I do that.
Yeah, I think it's the European way of writing a 7. I don't know, I've done it for as long as I can remember. Foreign, yeah.
You actually,
Yeah, yeah, Swansea.
That's funny.
Right, so 75, the number of 75 or over internet users. What percentage of people 75 or over use the internet? 40. How many over 75 do we have in Wales?
286500.
So to work out how many, that's what the hash is, yeah? I'm just saying number of. Number of 75 or over internet users is going to be 40% out of the 286,500 senior citizens there are. 1,146,000. So to work out the percentage now, it's the number of internet users 75 or over, which is the 114,600, out of the number of internet users in Wales, which we've worked out to be 2,677,500, and then to turn it into a percentage, we multiply by 100. So we type that in exactly as we see it. 114,600 2677500 times by 100. Okay, so always a good idea here. If the question is asking you to round something, it's always worth writing down what the whole string is before you round it, in case you mess up the rounding. So I've got to round this to 2 significant figures. That's different from 2 decimal places. Okay, sometimes they're the same, in this case they're not. The 2 most significant digits in that number are the ones with the biggest value, the biggest place value. So it's that one and that one, because that stands for 4 and that stands for 2/10. Okay? Joseph? So my answer is either going to be 4.2 or 4.3. Which is it closest to? 4.3. So that's...
Wait, so it's not the same then, rather than to...
No, because 2 decimal places,
Oh, of course.
you start counting after the decimal point.
Yeah, of course.
Okay? So significant figures, you start counting the first non-zero digit when you're moving from left to right.
100%.
So it's 4.3% of internet users in Wales are aged 75 or over. Okay. So we're into the CB questions now then. Question 8. In Cuba, urban gardens are used for food production. So here is an equivalence. Remember, we wrote down on the formula page the equivalence for the ones we're required to learn, and they'll give you anything you're not required to learn. So this is an equivalent to go from the unit of acre, which is a unit of area, usually measured fields and things like that. 1 acre is approximately equal to 0.00405 square kilometres. 35,000 acres of urban, God, losing my powers of speech. 35,000 acres of urban gardens in Cuba produced 3.4 million tonnes of food in 2002. Calculate the number of tonnes of food produced per square kilometre in urban gardens. So I need to turn my 35,000 acres into square kilometres first up. Okay, so if 1 acre is that many square kilometres, 35,000 acres is going to be 35 lots of that. Yeah, so turn acres into kilometres squared. So I've got 35,000 acres, and each of those times 0.00405. .75 square kilometres, and that amount of square kilometres .4 million tonnes is not that, that's 34 million tonnes. Is 3, 4 followed by 5 zeros. Okay? So I've taken my acres, I've turned them into square kilometres, and now I want to work out what per kilometre squared, what 1 kilometre squared will produce.
So is that 5 zeros?
Yeah. Yeah, it's 3.4, not 34 million tonnes. I wrote 1 million tonnes. So I need to turn my 141.75 into 1. And then whatever I've done to do that, I have to do the same here, like with a ratio. Okay? So what am I going to divide that by to turn it into 1?
Divided
By
141.
141.75. You divide it by itself and you get 1. So if I divide that side by 141.75, that gives me 1 square kilometre, and then I've got to do the same to the 3.4 million. So I've got to divide that by 141.75 as well. So 3, 4, 1, 2, 3, 4, 5. Now it doesn't ask you to round this, so you could round it, you could leave it as it is, you could round it to 239.86, 23986, doesn't matter, okay? It's not asking you to give it to a degree of accuracy. The mark scheme will say any answer between 23985 and 23986, accept. All right. Okay. I'm going to pause it there. Let's go for it. Right then. So for this question, there's lots of information in here. Formula 1 cars are some of the fastest racing cars in the world. The top speeds are up to 375 kilometers per hour, and their engines are limited to 15,000 rotations per minute. So the little spinny things inside rotate at 15,000 turns per minute. The Monaco Grand Prix is the shortest Formula 1 race, with 78 laps of the track, giving a total distance of 260.5 kilometers. Fernando Alonso won the Monaco Grand Prix in 2007. He completed the race with an average speed of 155.552 kilometers per hour. So we've got a little bit of information about speeds, a little bit of information about rotations per minute, and a total distance and number of laps. Complete the following statement. Top speeds of Formula 1 cars are up to blank miles per hour. Okay, so I know that the top speed in kilometers per hour is 375, so I've got to convert 375 kilometers into miles per hour. So this is one of the, I know it was before you came in, one of the things that I suggest you write down, unless you can memorize them, try and write them down straight away. It's this one. 8 kilometers is approximately 5 miles. Okay, that's the one we're going to use. We wrote them down when you were here last week, but like I say, you weren't here this week. So 8 kilometers is approximately 5 miles. That means 8 kilometers per hour is approximately 5 miles per hour. And I know that we've got 375 kilometers is what I want to work out, and I need to change that into miles. Okay, so if I want to work out what 1 kilometer is equivalent to, I would do 375 divided by 8, and that would give me 1 kilometer.
Can you do that with tangent?
Yeah. So you do 1 kilometer will be 375 divided by 8. Which is 46.875. And then you times that by 5. Hang on.
No, but you then times it by 374 because you've already used one of them.
I've used the 375 divided by... No, it is times 5. Times 5 equals 234. Yeah, that's right. So then I times that by 5 because I want to scale it up 5 times. So times 5 equals 234.375. So 234 or 235. Again, it's not asking you to give it to a degree of accuracy, but it's always safest to make sure somewhere on the paper you've written down what your calculator is telling you and then rounded it off. So that's conversion. Part B. Calculate Alonso's average lap time for the 2007 Monaco Grand Prix.
What, the shortest one? Sorry, going back. The shortest race is 78 laps.
78 laps, and that's a total distance of 260.5. So we want to work out first of all how far one lap is. Yeah? So 1 lap, distance for 1 lap will be the total distance of the race, which is 260.5, divided by the number of laps, which is 78. So 3.34 kilometers. Each lap is 3.34 kilometers. And the speed he's travelling is 155.552. Right. So another one you could have put at the front is your distance, speed, time little triangle. Okay? Speed is distance over time. I want to work out time. So if I want to work out the time, I cover up the t. Distance divided by speed, yeah? So distance over speed. So distance is 3.34. The speed 155.52. So that's equal to 0.02 watt. What units is that in?
Kilometers
It's time?
now. Miles now.
No. So they're going to be hours or minutes or seconds.
Minutes.
Seconds. Minutes.
What's the
Yes, there's only hours or minutes.
what's the unit of speed that we're using? In
Kilometers per hour.
per hour. So that unit is hours. Because the speed was in kilometers per hour. If we were measuring something in meters per second, then the time would be seconds, okay? But the question wants us to give our answer in minutes.
It does.
Okay? Just because this is grade B now, it's making you work.
Yeah, so 60, that's 120.
No, don't you just
No,
put a
90.
0.02 or something and add another 0 on it?
No. How many
No,
minutes
how
are
many
there in an
minutes
hour?
60.
60. So I got
So
times that by 60. So times that by 60 So it's 1 minute, 1.288 minutes. If you go half an hour, 0.5 of an hour, times 0.5 by 60, you get 30 minutes. Yes, you're timesing by 60. Which number from the list below would correctly complete the following statement? Formula 1 engines are limited to blank rotations per second. So I got 15,000 rotations per minute.
Divide that, or times that by 60, isn't it?
Yeah. So
Right, I'm going to give you a guess.
go on then.
The first one.
Oh no, I want you to tell me whether you're going to divide or times by 60.
Right. Times. Right. Then I thought you wanted it to be bigger.
So 15,000, if it turns 15,000 times in a minute, in a second, will it turn more than 15,000 or less than 15,000?
Less.
Less. So you're going to divide by 60. Because if you times by 60, it would make the number bigger.
Okay.
Yeah? So divide by 60, and we get 15,000 divided by 60, 250. That's a horrible question, that is. Because it's got 3 different parts to it which are completely different maths. You've got a metric to imperial conversion, then you've got distance, speed, time, then you've got just something completely arbitrary, and you've got to lift all of the right numbers out of that. Horrible question.
Let's hope that one doesn't come up in the exam.
Well, it won't, because it won't come up again, but questions like it with slightly different context will. Oh, right, exchange rates. Typical exchange rates in 2018 were as follows. £1 gets you 1.38 US dollars, and £1 gets you 1.14 euros. In 2018, the average annual cost of running a Formula 1 racing team was $250 million US dollars. Complete the following statement. The average monthly cost of running a Formula 1 race team was blank million euros. So the first thing I got to do is turn my dollars into euros. But I'm not given an exchange rate for US dollars into euros, so I got to change it to pounds first of all. Okay, so pounds times by 1.38 gives me dollars. I'm given $250 million, and I've got to turn them into pounds, so I've got to go in the opposite direction from my times 1.38. So rather than multiplying by 1.38, I'm going to divide by 1.38.
Why can't we all just have all the same money?
Because then maths teachers would have to find something else that'd be horrible. So that's going to be 181 million.
Is that two? 250.
So $250 million. I've got to turn it into pounds, so I've got to divide by 1.38 because I'm going backwards. Then I got my 181 million pounds, and I know that pounds into euros are times by 1.14. And this time I'm going the right way. I know I've got the 181 million pounds, so I'm going to multiply that by 1.14 now. And that gives me times 1.14, so 206 million euros. That'll get you 3 marks, because there's one other difference. Which again, by now the kids sitting the exam are knackered, coming towards the end, and they're not reading as carefully. The information they give you is for an annual cost. They want this written as a monthly cost.
So you just divide it by 12?
Just divided by 12. But an awful lot of people wouldn't have seen that. So you got 17.2 million. Okay. So most of the time, an exchange rate questions early in the paper is normally a grade C, but that one, because it's harder, because you've got to go from one to another currency and then to a third, makes it a grade B question. Okay, question 10. This is something else we'll cover in the next couple of weeks as well, which is errors in measurement. So Ruth measures the lengths of 5 square pictures. The measurements she records are as follows. So one of them is 21 centimetres, 122, 123, 124, 126. Each of these measurements is correct to the nearest centimetre. Now they've even started putting that in bold, okay? Because that tells you this is a grade B question. Because otherwise, if we read through it, she plans to display all 5 pictures in a line edge to edge on a shelf of a bookcase. The length of the shelf is 120 centimetres, correct to the nearest 5 centimetres. So these measurements have been rounded. Show that the shelf could be 1 centimetre too short to display all 5 of these pictures. So what's happened in the past with questions like this is the kids have just read it and said, well, I've just got to add those numbers up. And if those numbers are smaller than the 120 centimetre length of the shelf, they're going to fit. But that's not what you have to do. Because they've been rounded, because those measurements have been rounded to the nearest centimetre, that value there could be as low as 20.5.
Yeah.
And could be as high as 21.49999 recurring, but we call it 21.5. Anything between those two numbers, if I say, well, just give it to me correct to the nearest centimetre, would round 21. For this one, it could be anything as low as 21.5 or as big as 22.5. Anything between those two would round to 22. This one, anything as small as 22.5 and as big as 23.5 rounds to 23. 24 is anything between 24 and 24.5, and 26 is between 25.5 and 26.5. So if those pictures were all at their biggest possible length, we could work out what their total length was. Okay? If pictures are all at max length, they would total. So the first one would be 21.5 centimetres. The second one would be 22.5. The third one would be 23.5. Then would be 24.5. And the next one would be 26.5. So their total length would be 118.5 centimetres. That's the worst case scenario. That's the biggest distance that those pictures could measure. Now the chances are some of them would be a little bit less, some of them could be at their maximum, but it would be impossible for them to be any wider in total than 118.5. Now let's look at the shelf. The length of the shelf is 120 centimetres, correct to the nearest 5. Okay, so if I asked you to measure something and you were rounding to the nearest 5 centimetres, what would be the next measurement down from that you would be reading off for me? If you're rounding to the nearest 5, what would be the next one down from it?
Like the lowest you could get.
Not the lowest you could round. So if you were measuring to the nearest...
Sorry for the interruption, but the sapphire alarm will sound one more time. This will be a continued ring, and I'm no need for alarm. Thank you.
Unbelievable.
It would be what?
It's going to be a continued ring and no need for alarm. Well, I don't know. So if you're rounding to the nearest centimetre, then you're going up in counts of centimetres. So 1 centimetre, 2 centimetre, 3 centimetre, 4 centimetre. If you're rounding to the nearest 10, you'll be going 10 centimetres, 20 centimetres, 30 centimetres, 40 centimetres.
So if you run,
So if you're going to the nearest 5,
wouldn't it be
17.5, or would it be 150?
right, you've answered both bits of the question there. So let's go with 115. Yeah? That would be the next round down, and the next round up would be 125. Good. So when you round into the nearest 5 centimetres, you're moving in jumps of 5. So what we've got to work out now is, because our measurement is that, cut-off point that rounds to 120.
117.5.
Good.
No.
No. 122.5. Okay, anything between those measurements rounds to 120. So min, max. So the worst case scenario is that all your picture frames are at their maximum, in which case they'd have a total length of 118.5, and your shelf
So it'd be like
has got a minimum.
Minimum it would be 1 centimetre too short.
Perfect. Okay. So worst case would be shelf at min 117.5 and all pics at maximum. Which is 118.5. So, and there's your 1 centimetre difference. So we'll do some practice on that, like I said, the week after next probably, because once you get in the habit of those, they're quite easy questions. Okay. Okay. A couple more questions.
Just literally have the lid on.
Okay, standard form. So in March 2014, there were an estimated big number of 2p coins in circulation. Calculate the value of these 2p coins in pounds. Give your answer in standard form.
So that's how many 2 pences there were in the world.
So that was how many 2p there were in the UK, yeah. Okay, and each one of them is worth 2 pence. Or in pounds, 0.02. Yeah? So we've got 6, 5, 5, 0, 0, 0, 0, 0, 0, 0, 7 noughts, 1, 2, 3, 4, 5, 6, 7, times, to work out its value in pounds. One, 2, 3, 4, 5, 6, 7 times 0.02. So that gets me 2 marks. In order to get the 3rd mark, I've got to give my answer in standard form.
What would it be? 1,
So it's got to be a number between 1 and 10.
131.
1.31.
Times 10 to the power of 6. Would it be 6?
What 8?
Let me show you.
It's numbers after decimal point, so.
So there's decimal point.
Uh-huh.
That's where your decimal point would be, yeah?
Yeah.
So 1, 2, 3, 4, 5, 6, 7, 8. You think?
6. Yeah.
The way that I would teach this, if I was teaching you standard form from the word go, okay, is I'd be putting the, if you think of units, hundreds, tens, thousands,
Yeah.
as powers of 10, the first one is 10 to the power of 0, 10 to the power of 1, 3, 4, 5,
What did you
6,
go until?
7, 8. Okay, so you keep going until you end up with a number between 1 and 10. Okay? So if it was... So what you're saying here is you've got 131 million, which would be 131 0,000 times 10 to the naught. Or you'd have 13.1 million, 13.100 times 10 to the 1. So because we're in this column, it's times 10 to the 8. So it's going to be 1.31 times 10 to the 8. Or, the way probably you remember it is you say, right, well, there's my decimal point. I need to move my decimal point until it gets between the 1 and the 3. How many times do I have to move it? Once, twice, 3, 4, 5, 6, 7, 8. It's got 8 jumps, so it's times 10 to the 8. The 2 pence coin is made from a mixture of metals. It has a diameter of 25.9 millimeters and a thickness of 2.03 millimeters. The 2 pence coin can be considered to be a cylinder. Okay, so it's got a diameter of 25.9.
Ladies and gentlemen, allow me to stand up one more time. More please advance.
Quite funny.
He said that about 4 times now.
He has, he's promised. So if it's got a diameter of 2.03, its radius is going to be half of that. So the radius would be 25.9 divided by 2. So 12.95. One of the other ones that we wrote down at the front when we came in was the volume of a cylinder is pi r squared times height. So it's basically the area of the cross section, which is a circle, times the height. So the volume will be pi times 12.95 squared times 2.03. So when you calculate, you've got a pi button, which on this one is shift times 10. So shift pi times 12.95 squared times 2.03 equals that. 1069.511 da 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 da. Again, it's not asking you to give it to any degree of accuracy, so you can just write it like that, and it's not asking you for the units, so you don't need to put them in, but it'll be millimeters cubed because all our measurements are in millimeters. Okay?
Yeah.
Rightio.
Can I have that sheet? I
Yeah.
finished enough, but before we just.
What did I just do with it? Right, so we're on a calculator allowed paper. It's almost certainly going to have a Pythag or a trig question.
Can I ask you a huge favour?
Yeah,
Can you double check that before? Because I've done the entry.
Yes. yeah,
Oh, that's right.
okay. For the morning?
I think so. I don't know when she needs it by. She's going.
Yeah, no problem.
So if you check it, just pass
Yep,
it on.
okay.
Thank you.
Yeah, so there's going to be a trig question. It's not going to. You're never going to get trig on a paper one because you need a calculator. It's intermediate tier, so it's only right-angled trig. You don't have to worry about the sine rule and the cosine rule that you would have done in year 10. We'll worry about that when we do higher tier maths. So you've got your.
It's the same question, just on a different page of it.
This is a different one now. We finished with.
No, I mean like. Well,
They're both slightly different. Okay, so you've got your little trig triangles. The Leaning Tower of Pisa stands on horizontal ground. The vertical height of the tower on the higher side is 56.7. The top of the tower is displaced 3.9 metres horizontally. Calculate the angle at which the tower leans. Give your answer to 2 decimal places. You must show all your work. So we need to decide which of those 3 trig relationships we're going to use. So we're going to name our sides, yeah? Can you tell me what's what? Opposites and hypotenuses and adjacents?
Hypotenuse is the long.
Hypotenuse is the long one, which is this one here, yeah? Pointed at, if you turn the box into an arrow, it tells you where it is. So that's the hype, yeah?
And then the opposite is the 56.7, is it?
No. So the opposite is always pointed at by the angle you know or you're trying to find. Okay, so if that's the angle, that's the opposite, and the adjacent is then the one that's left. Okay. Now, I need to find the angle in this one. So in order to find the angle, I need the triangle up here, which has got both of these sides in it. Okay? So it's got to have the O in it, it's got to have the A in it.
the last
Tower.
one.
The last one, yeah? So it's TOA. So we're going to be using this one. And when you're trying to find the angle, it's the S, C or T we cover up. So tan of the angle is going to equal opposite over adjacent. 3.9 over 56.7. And then to get the x on its own, I've got to undo the tan. I've got to do the opposite of tanning. Now if you look in your calculator, your buttons are sine, cos, tan, and the opposite of them is above it. So it's the tan minus 1. Okay? So x is going to be tan minus 1 of 3.9 over 56.7. and we put it into the calculator exactly as we've written it. So shift tan gives us a tan minus 1. Fraction button, 3.9, 56.7, close bracket. 3.9 degrees. Oh, 2 decimal places, right. So let's write lots of decimal places. And then 2 decimal places will be 2 numbers after the decimal point. 3.93 degrees. Yeah? Because it's 2 decimal places. B. Kerry plans to make a poster that is mathematically similar to the Leaning Tower of Pisa. Okay, mathematically similar is again similarity. We will look at these in the weeks leading up to the exam. In the higher tier, you would have done similar areas and similar volumes. Intermediate tier, it's only similar sides that we need to worry about. Okay, so what they're saying here is that I've got this triangle over here, which I'm going to copy over here. So that's 3.9, that's 56.7, and I want to work out the height of Kerry's poster. So I want to work that out. Okay? So because they're similar, it means that whatever the scale factor is between these two, whatever I've got to multiply that by to turn it into that, I have to multiply every other side by the same value to get
What have you got?
3.9.
No, 3.9.
so this triangle here,
Oh,
yeah? So all I've done is copy that over there.
Alright,
Okay? So in order so that that is similar to that, basically what that means is, you know, when you copy and paste something into, say, a photograph or something into a document, and you try to enlarge it, when you pinch the bottom corner and enlarge it, it stretches both sides, so it keeps it similar. Whereas if you pull it, stretch it horizontally, boom, it goes out of shape. Okay, so if you're changing its size but keeping it similar, it means everything changes by the same scale factor. So what you've got to do here is work out what you have to multiply 3.9 by to get 9.36. That's the scale factor. So to do that, you'll do 9.36 divided by 3.9. So everything is 2.4 times bigger. So the height will be 56.7 times 2.4. So 136.08 centimeters. The trigger word there is the similar. Okay, and as I said, we'll
So it's like it's the same, but it's just been big.
it's been multiplied by a scale factor. Yeah, and we'll practice those as well because they're.
Why is that like? Why is the Leaning Tower like that? Was it made like that on purpose?
No, it was built on a soft ground. So it starts as lean, and then they pump loads of concrete in to try and stop the fall. Okay, this will take,
My nan-
this won't take long now.
Okay.
Okay, it's last question. And it depends whether or not you can remember it really. So cumulative frequency is what we would be doing tomorrow if I hadn't decided to do a test. So on Wednesday there were no cars in the car park when it opened at 7 a.m. From 7 a.m. the number of cars entering the car park was recorded. The cumulative frequency diagram has been drawn from the results. How many cars had entered the car park by 7:35 a.m.? So you're going across to 7:35, you're reading up, and you've got 45. The first car entered the car park at 7:21 a.m. and the last car entered the car park at 7:44 a.m. Draw a box and whisker plot showing this, using this information and data from the cumulative frequency diagram. One of the other things that sometimes I would get people to write on that front formula page when they come in is what the main bits of a box and whisker diagram are. And I'll talk to you about this next week. That's the minimum value. That's the max value. And then when we're talking about cumulative frequency, we talk about medians and interquartile ranges. And with interquartile ranges, we've got an upper quartile and a lower quartile. Okay? Which are words you probably haven't heard in a year, but you did do in year 10, because I've checked your books. This is the lower quartile. That's the upper quartile. And that's the median. Now, median we've spoken about a lot in the last week. Where do I find the median in a set of data? Think back, mean, mode, median. The median is where in the data? Middle. Okay? So this is telling me that I've got up to 60 cars.
So where is it at 30?
So I'm at 30. So for the median, I'm there. So I read down, and it's at 725. Okay? So my median is going to be this line here. My minimum value is at 721. Okay, so if we look at the times here, two little squares is going to be a minute. 721, 722, 723, 724, 725. So the first car entered the car park at 721. I'm going to put a cross there for my minimum value. 744 is my maximum value. And now I've got to put my other two bits on my box. So the median is the halfway point. The lower quartile is at a quarter of the data,
Which
is going to be
15.
15. So my lower quartile is that one, which is halfway between 720 and 725.
And 45 is going to be...
And then 45 will be the upper quartile. Which would be at 735, yeah? So that gives me my box. And that gives me my whiskers. And that's it.
So what time did you put your lower quartile up?
My lower quartile, it's exactly halfway between 720 and 725. So this scale on this axis is exactly the same. So you could just put it on rather than work it out. Probably on the higher tier paper there'd be a part C to that where they'd ask you to start comparing. But on that one it's a nice easy one. Okay. So that was, November 2020.